Okay, so this is 1.3, solving equations with variables on both sides. So section 1.3, we're going to be solving equations with variables on both sides. Best way to do these is just look at some examples. 10 subtract 4x is equal to negative 9x. This looks different. We haven't seen these before where I've had a variable on both sides of the equation. We still are always going to look to see if we can simplify on both sides of the equation first. And I'm going to look at this left side, 10 minus 4x. 10 and minus 4x are not like terms. I can't combine them. There's no distribution, so I'm done. If I look at the right, well, that's just negative 9x. Nothing I can do with that. Next step is going to be to gather your variable on one side of the equation. And I can see right now that if I move this 4x over with the negative 9, I will have my variable on one side of the equation. Then I can solve for x. In order to combine these like terms when they are on opposite sides of the equal signs, I have to use inverse operations. I can't just say negative 9x plus, or I'm sorry, negative 4x plus a negative 9x and make that negative 13x. They're on opposite sides of the equal sign. I need to use inverse operations. I definitely want to combine these two, but when I do, I use inverse operations. What I do to one side of the equation, I must do to the other. So if I choose to add 4x, which I can do, this 10 stays, that goes away. Negative 9x plus 4x leaves me with a negative 5x. Now I've just got a one-stepper to solve it. X is being multiplied by negative 5, so I would divide by negative 5. 10 divided by negative 5, negative 2 is equal to x. And I can certainly plug this in and check it. Plug it in for the x's right there. 10 minus 4 times a minus 2, and I want to know, does that equal negative 9 times negative 2? Well, 10, negative 4 times a negative 2 is a positive 8. Negative 9 times negative 2, 18. Look at that. 18 equals 18. It checks, and I will box in my answer. Now I can look right here. Back to this step right here. One thing we've got to pay attention to. I'm going to rewrite this equation. I certainly, in this situation here, could have added 9x to both sides. But when I do that, look what happens. If I add 9x here and 9x here, I'm actually getting farther away from solving the problem. 10 minus, or I'm sorry, it'd be a negative 4x plus 9x would leave me with a positive 5x is equal to negative 9x plus 9x is equal to 0. And I can still solve this by subtracting 10. 5x is equal to negative 10. I would divide by 5. X is then equal to negative 2. And yes, I get the exact same answer. My point being, though, when I add extra steps, I add the potential for errors. You need to start looking at these equations before and think about what's going on and what would be the easiest way to do it. I can absolutely get the solution by doing it this way, but I'll tell you right now, this negative 9x plus 9x equal to 0, and when I have this equation equal to 0, it creates issues. Sometimes we'll have no choice and have to get it equal to 0. When I have the choice right here, I can see in this equation, in one step by adding 4x, I was ready to solve for x. Down here, by adding 9x, one step, then subtract 10, 2 steps, then divide by 5, 3 steps. I just turned that into a 3-step problem instead of a 2-step problem. Less steps is better. Start looking at the equations and thinking about what's going to be easiest and how can I solve this. M subtract 4 is equal to 2m. I notice there's nothing to simplify on either side of the equation, no like terms to combine, no distribution. If I choose to subtract 2m, I'm right back where I was over here. In one simple step, if I get this m over to the other side, I'll have m by itself. Let's do that. This is a positive 1m. Remember, there's really a 1 there. So to move that m over, I use inverse operations. What I do to one side, I must do to the other. That would go away. Negative 4 then is equal to 2 minus m, or 2 minus 1m is just m. And I've got m by itself. And I can certainly test this by plugging negative 4 in for m. Negative 4 minus 4, well, that's negative 8. 2 times negative 4, well, that's negative 8. That definitely checks. And I'm done. Be careful when you're moving your variable and it's positive. Remember, I want to subtract it. We'll amp it up here a little bit. I have 3k minus 1 is equal to 7k plus 2. 7k plus 2. Now in this situation right here, I've got a choice to make again. I could move the 7k or move the 3k. But then all of a sudden I notice I've also got these numbers. How is this equation different from the first two we did? Well, now, if you notice, I have got variables on both sides and I have integers on both sides. I'm going to have to combine both of those. I'm going to have to get my variables on one side and my numbers on the other, or vice versa. I'm left with this decision here. I know I'm going to have to move the 7k or the 3k, and I know I'm going to have to move the negative 1 or the 2. What I want us to think about is the order that we're going to do this in. In this situation, I like subtracting 3k first. You will always see me work with my variables first, and I like subtracting 3k first. Why do I like that? Because I can see right here, this is a positive 3k, so if I subtract it from both sides, I'm going to have a positive variable here on the right. That would go away. Don't forget your negative. That negative 1 comes down. 7k minus 3k, 4k plus 2. Now, all I got to do is move this 2 over. If I subtract 2 from both sides, negative 1 minus 2 is negative 3 is equal to 4k. K is being multiplied by 4, so I would divide both sides by 4. That leaves me with negative 3/4 is equal to k. That can't possibly be right. I got a fraction. Well, if you don't believe me, plug it back in. 0.75 times 3 minus 1 is equal to 7 times negative 0.75 plus 2. You can certainly plug that 3/4 in and see if you get a true statement. I will tell you that we will get fractions and we will get decimals for our answer. Next example. I have 12 times the quantity. 2w minus 3 is equal to 6w. And again, I'm going to look and see what's going on in this equation. I definitely am going to have variables on both sides, but I can see here on the left, now I've got some simplifying to do. Up here, I had numbers on both sides, variables on both sides, but I didn't have any simplifying to do until I started moving stuff around to get the variable by itself. Here though, I definitely have distribution, and I need to do that first. I need to simplify both sides of the equation first, and with this, that involves distribution. 12 times 2w, 24w, minus 12 times 3, well, 36. 12 times negative 3, negative 36, is equal to 6w. Now, I can definitely see that I'm going to have to subtract 24w, and I'm going to want to do that, even though my variable is going to be negative, because if I have 6 minus 24, my sum will definitely be negative. But I certainly don't want to subtract 6w and add an extra step just to keep my variable positive. So in this situation, I'm going to subtract 24w. That leaves me with negative 36 is equal to 6 minus 24w, negative 18w. I would divide both sides by negative 18. 36, negative 36 divided by a negative 18. If I put that in my calculator, 2 is equal to w. I can check that. 2 times 2 is 4. 4 minus 3 is 1. 1 times 12 is 12. What's 6 times 2? Well, that's 12. That would check. I would box that in. Distribute. You may have to do it on both sides. Then start getting that variable by itself. I'm going to flip my paper over. Next example. Going to amp it up a little bit. I have 2 times 4x minus 7 is equal to 3 times x plus 2. I can see already what's different about this problem than the one we just did. Well, I've got distribution on both sides, and once I distribute, I'm going to have numbers with variables, and I'm just going to have numbers by themselves. I'm going to have some like terms to combine. First step, distribute. 2 times 4x, 8x. 2 times negative 7, negative 14. 3 times x, 3x. 3 times 2 plus 6. All I did was distribute.